All right, hello everyone, and welcome back. And is my sound recording? Yes, it is. I'm just going to leave that in there because I'm so professional. Welcome to the uh, series where we are creating a programming language from scratch. C++, Bison, Flex, Doxygen, ICU, Vim as our editor. Yes, we're doing it all 100% live coding, which means my mistakes, my syntax errors, debugging, everything. The goal is for you to be able to see the process. What does it really look like to code? And make fun of me for being so obtuse at times, I suppose. My name is Corey, and we're on episode, I don't even remember the number. We're on episode 23. That's pretty good. It is still Halloween for me. I'm doing 2 videos today, which is why I'm in my Halloween outfit. And in case you're wondering, that is, I am dressed like my chair. So I actually tried to find a green shirt that was the right shade so that I would look invisible, but it didn't work. I'll have to do that another time. I know you're heartbroken over that. So anyway, we want to jump in, and what we're doing today is we're going to be... Actually, this one scares me because it's big. There's a lot of parts that have to happen, and I don't know if we can get it all done in a reasonable amount of time, but my goal is to be able to have variables. A is equal to, and so that's a variable, that's an assignment operator because you can't have an assignment without variables, and variables are generally useless without an assignment operator, at least in such a simple language as ours. And in order to do that, well, they have to have an initial value, and I don't want it to be garbage, so they're going to be initialized as a null, so we've got to have a null type. And yeah, we're just going to have to jump in. And I've told you before that, yes, I have written a programming language twice in preparation for this, doing it different ways, but I'm not copying. We are going from scratch. There's a structure in my head, and whether or not it's fully fleshed out or not, we'll see. We're going to start here, and let's do a couple things. First of all, I know that we're going to have to add a null opcode. Okay, so let's, of course, where am I? If I say git log, you can see I am indeed at the end of episode 22, and we're at the beginning of 23. So, as I said before, nothing up my sleeves. We're just picking up where we left off. And I'm going to edit the include opcode. There we go. And we've got these types, integer, float, boolean. I think I want to add it before integer because to me that is a... Will it let me call it null? Is that a reserved word in C++ now? I don't know. And we're going to say it's push a null onto the stack. I hope that doesn't give us issues. Let's make test and see if it complains. I think it's going to. Yeah. What do I want to do? How about null value? You say, Corey, I don't like that. Neither do I. But that's what it's going to take to get this to compile. Okay, so null val. Just help me remember that. That's your job. Now, we're going to exit here. Why? Because I'm going to edit the make file, and I like to do that separately so that it doesn't mess up my tabs and everything. I mean, when I open a make file, it switches to using tabs by default, and then that completely messes up when I try to switch back to the C++ for some reason, and I don't know why. But why am I going down there? We need an AST node null. And where are we going to put this? AST node integer. And let's just copy that. And call this null. Okay, and now we need to copy and pasted that. We need to now replace. What lines are these? 76. I said there's bound to be a way of doing relative numbers as opposed to exact numbers. I just don't know what it is yet. So, but we're going to replace integer with null, and there. We did it, and now it's going to complain because it can't find these. That's fine. We're about to copy, and so we're going to copy the include for AST node integer, and we're going to call this include AST node null.hpp, and we're going to copy the include for AST node, not include, the source for AST node integer, and we will call that source AST node null.cpp. And now let's edit those. Our include AST node null and our source AST node null. All right, a null doesn't need anything. Well, let's actually %s. We're going to change integer to null, and we'll do that for the title case stuff as well. %s integer to null. There we go. All right, now that represents a null value. Sure. The constructor, it doesn't need any parameter except for the location. And it doesn't have anything in the private section there. Sure, why not? And now we need to edit the this here. Let's change, do the two substitutions. And now instead of null, it needs to be null val. I'm sorry, we had to call it that. I'm not happy about it, but anyway, all right. And so for the make copy, we don't need to pass it anything. There's nothing there. Indent. My caps lock is on. There we go. When I turn off the caps lock, my brain thinks I've hit escape, and that is not what I have done. So that is, yeah, just null. That should be fine for the dump. For the constructor, we don't need any of that. We don't need any of that. Is it that simple? Okay, so we've got that. Now it's compiling. We also need a computed expression value of null. Yeah, computed expression value of null. So we're going to do the same process. Our make file. I should have done these all at the same time, but I wasn't thinking. So computed expression. Let's see. I think I want to try to keep these in alphabetical order, so I'll put it there, and instead of integer, it'll be null. Okay. I'm getting rid of that extra space because it's bothering me. So computed expression null. And we're going to look for integer. There's an AST node integer. There's a computed expression integer. And we'll put it, well, error. That's fine. We'll put it right there. Computed expression. Oh, wait. We can do it here. What is it? 116 and 117. Integer for null. Yeah. And now we need to copy these. So copy the include for computed expression integer, and we're going to, it's going to be the include for computed expression null.hpp, and do the same thing for the source computed expression integer source computed expression null.cpp. Yep, now we've got to edit them because the computer is now panicking because they have the exact same contents, and it's like, no, you've declared things twice. Okay, so include computed expression, not null, not integer, but null, and source computed expression null. All right, now we need to switch out the all caps, and we'll do it again with the title case. Well, okay. There we go. And now let's see what we need to do to this. As a result of a computation. Sure, why not? Because it might be. There is no value to pass in. We're going to have a dump. Make copy, suppose, is equal. What do we do for an is equal to null? I'm just wondering, can I just use the word void? I don't think so. I'll think about it. But I don't need the is equal for int and double because it's going to just say no. It doesn't work. I don't need to add, subtract, multiply, divide, modulo, negative, not, less than. I do need an equal. We'll leave that. So, and then integer float boolean. So we're not going to be able to cast it to any of those. So let's just get rid of those. Don't need to leave the friend class, and don't need anything private. Okay, that seems pretty straightforward. Let's do the same things here. All caps? Is there an all caps? I guess not. Okay, now we're gonna need to remove some stuff. Don't think I need Boolean. Do I need error? I might. I'll leave it. Dump. Return. So if I'm dumping it, what should it look like? It should be null. Okay. Make copy, return a new computed expression. That shouldn't be doing that. Oh, no, wait, well. Make copy, shouldn't that be a garbage collected value? Shouldn't it? Because I didn't think we were dealing with any raw pointers anymore. There. Computed expression null. That's what I thought it should be. Don't need the is equals, so let's remove those. Don't need... I deleted too much because we need equal. So and so we're saying if the type ID is computed expression null. Don't need to convert it. Just return garbage collected make computed expression boolean. And true. Else, don't know how to compare. That's fine. Should that be the case, or should I just say it will always return a false? Maybe. I think I like that better. Okay, don't need to be able to do that. So I think it's going to complain. Right here. Probably doesn't know what a computed expression Boolean is. Okay, Corey, start looking at the error messages. No declaration matches. Oh, yeah, gotta fix the. The constructor, there we go. Make copy. I could have sworn that all the make copies, and you know what? It's almost as if I needed some documentation. So on the classes, the computed expression, I just want computed expression and what am I, the make copy. Oh, that's right. Wait. Sorry, I'm just thinking ahead. So, a float make copy is, where am I using make copy? So I know it's waiting for changes. I just want to do this. So git grep -in. Ooh, it's not going to like it. Or it's going to give me a lot of documentation stuff. So I'm going to go into source and say git grep -n make copy. All right, where is this needed? It's declared for AST node. It's the binary. Oh, these are AST nodes that have the make copy. Do I ever use it for the computed expression? Do I ever call it? I use it for the ASTs. And that may not even be necessary anymore since I'm not using memory allocation. Okay, so here's what I'm going to do. For the moment, I'm going to... I didn't mean to do that. 0. I'm going to call this a computed expression star, and I will say a new computed expression null, just so that we can get it compiling. And I'm going to revisit that. I may be able to yank out all of these make copies. Because again, that was just to get... Yeah. Okay. Test-watch. Okay. And looks like it's compiling. That's fine. Now, so we've got this computed expression null that only equals itself. And we've got our AST node, we need to tell our program how to recognize it. So we can do that with our source program. Let's look at the dump bytecode. I had it right before integer. Well, here, let's just copy pop. And I called this null val. Much to my dismay. And we're going to edit the source for program execute. And again, we'll do the pop. And we don't need to do a stack check. What is its name? It is null val. And we're going to do a stack.pushback garbage collected make computed expression integer and not integer, computed expression null. Pass it nothing. It should be happy. Computer expression null was not defined. Okay, fine. Okay, so now it's compiling. We should, in theory, be able to, create this. We need to tell Flex and Bison about them. So we're going to edit Flex, and where is this going to be? Here, let's just do there. And this is going to be what do I want this to be called? Do I want it all lowercase, or do I want it all uppercase, or do I want it NULL? I don't like NULL. I mean the title case. I think I just want to stick with NULL. And this is going to be null at that location. Okay, it's going to say I don't know how to do that because it doesn't exist, and I'll say of course it does, I just haven't told you about it yet. And so now we're going to go to our tokens and percent token, and this is a null that we will call null. All right, and it's an identifier, so it's an expression type, right? So we go down. An expression can be an integer or float. Well, now we're about to there. If I see a null, then I will make shared AST node null. Whoops. Null, and I only need to give it the location. See if that compiles, or what does it not? It doesn't know what an AST node null is because for some reason we didn't tell it about it. We need to include it. So AST node integer, AST node null. Okay, that's always good. Okay, all of our tests are passing. Now, if we edit our test, we're going to do a... I don't think... you know what? Let's go into the edit the include for garbage collected. Well, for that matter, we're going to need the source for garbage collected. Okay, and let's check out the is. Okay, where would this be? Compare see, we don't have what I'm wanting is like a C++ type to represent null. That's what I want. I mean, I know a pointer, but I don't think it has the idea of a, an actual null pointer constant. You know, can I use that? Null pointer t. That's a very good question. I'm glad you asked. I'm just gonna say and see if it gives me an error. I mean, it's not going to be defined, so. Ampersand null. There we go. And for our at this point, by the way, I am truly just not sure. So I'm going to return false. Okay. So far it's, I said maybe unused, but that is not exactly right. I want to do that. Val. And computed expression. What's it not? Oh, yeah. I think it's because I need to add this now to the computed expression. So, do I already have the computed expression? No, I don't. So, edit the include. No. Computed expression.hpp. And we're looking for is equal. There we go. Is equal, and null pointer t. Source computed expression.cpp. Doing good so far. Okay, now let's go back to our test. And that is buffer 7. And I want to say, Corey, all this for a null? Yes, all of this for a null. There we go. And we're going to, what did I say? Was it null? N. Null. Should give me a false. Oh, test. Remember, you're not supposed to let me make stupid mistakes like that. Okay. Saying ambiguous overload for operator equal, garbage collected, and const long int. So would it like null PTR explicitly? It does. Okay. Now, we need to, in my, is this computed expression? Yes. So our computed expression is equal computed expression null. Is it equal to yes? I just almost wrote the word yes instead of true, which is funny because in your language, if you wanted to make your Booleans yes and no instead of true and false, you could do that. It's your language. So this I need to add no. There we go. And we need to do that is equal override. See if it likes it. Our test should pass now, because the only thing that'll make it there is yes. So now we have a true that we can, a null that we can test against. And let's go back to the test, which is buffer 7. And now let's go down to our equal, greater than equal to, yeah, our double equal. And we've got our false is equal to true being false. R6, R7, R8. Okay. One thing that we did not do, we did not test does true is equal to true. That should be true. Does false equal to false? And that should be true. And now null equal to null. That should be false, but oh wait, no, that should be true. Whatever. True, false, whatever. But null is equal to 0 should be false. That's different, right? I mean, you can define how your programming language acts, but in my mind, null means no value. 0 is a value. It's just the value is 0. So, and while we may say that, well, a 0 and false are equivalent, and non-zero values are truthy, they're not true, they're truthy, I'm saying null will only match against itself. I think JavaScript doesn't even do that. I think it they do their own thing. So, oh, P18 is reused. So 19, 19. Now, the only other thing is if I were to go in and now say on the is equal, or for the equality test, what if I did 0 is equal to null? It's going to give me an error saying don't know how to compare them. Well, it will once I... $20, $20. Yeah, don't know how to compare these values. So at this point, we're 40 minutes in, and we don't have null fully done. That is, I need to take into account the null in comparing it versus a... What all are my types? I've got a float, and a Boolean. Do I have any others? I don't have a way of instantiating an error type, but and all of these are going to fail. Well, again, all of those will fail, and it's because we need to add code. So we can do that fast enough, I suppose. Source, sorry, brain stopped working. Computed expression integer, well, Boolean, that's fine. We got to do a Boolean as well. If the is equal to null, simple enough. We're going to edit the source for computed expression error. We'll just add that in. Oh yeah, an error will always error, so we don't have to worry about that. Edit the source for computed expression float. And don't need to do the is equal. We need to find the underscore equal. There we go. We are there. And we got that. Oh, we've got to add the... That's okay. We'll do that in just a moment after we get all of these. Edit the source for computed expression. We just did float. Let's do integer. And we're looking for... There we go. And are there any others? Source, computed expression, float integer, null. We don't need to... Okay. We don't need to do that. All right. Now we need to add a pound include for computed expression null. There we go. Now, you say, Corey, you sure do say a lot. Well, I'm thinking out loud. We're in the Boolean, so... Is that all of them? I think we got all of them. Yeah, we're passing all of our tests. That's always a good thing. So I think at this point, what did I put on the title screen? Null, variables, and assignments. Oddly enough, I think that this needs to be our stopping point for this particular video. That is, I need to break this up, and I'm probably about to just record part 3 directly after this, but it's going to be probably an hour and a half in and of itself, because quite frankly variables are complicated, but we did have to have this null value available to us, and because the variables have to be initialized as something, and yeah. So having said all that, let's wrap up everything. I know that we need to so that can be closed, that can be closed, that one can be closed. Our tests can be closed, but okay, that can be closed. This one can be closed. You're saying, Corey, why do you keep reading them off? Because one of them can't be yet. This one right here. we need to give it some, okay, is equal to another value. That's fine. So that one, we can close that. We can close that one. That should be fine. This one is our program execute. We're good there. It's our dump. Hey. Check out our diff. Does anything look amiss? No, it doesn't. And it's always handy to see. Yeah, we're growing. We're almost at 3,000 lines. I'm kind of expecting this project to maybe hit 8 to 10,000 total. We are, well, this is what, number 22 or 23? I'm going to have to look again. I don't remember the numbers. They'll just kind of meld together. But calendar day-wise, I only started this 3 weeks ago. I mean, actually, I think it's 20 days, maybe. Yeah. So, git commit -m, oh, -am. Wait, no. Corey, stop. Git add our include AST node, our include computed expression null, our source AST node null, our source computed expression null, and everything else with a -a. So git commit -am and add a null expression type to the language. And regenerate our docs. Maybe I should just, no, I don't want to always do the RMRF. The only reason I do that is if files disappear, they don't just, I mean, if it doesn't need a file. The only time, though, that really happens is if you change around your directories. Like when I renamed AST to AST.hpp to ASTnode.hpp. Things like that. So I guess I didn't need to do it here. But make docs-pdf. Generate everything. The computer starts sounding like an airplane taking off. And there we go. For episode, sorry, I don't remember. Episode 23. Okay. For episode 23. Okay, it is there. And so where does that put us? Well, we've got in our whatever this is called in our documentation. We have our classes now. We've got there's the block from last time. We've got our null. And I just like making sure that I have all of my documentation lined out. And if we were to click on this AST node null, we can see, yeah, I like how these start getting filled out. Okay. Well, I guess this is the end of part 1. And now we're going to have to jump into part 2 next. And I'm still going to be, because it's, well, for another hour and 10 minutes, it's still Halloween. So I'm going to keep on my chair. I'm dressed like my chair costume. And yeah, I will see you in that one. So thank you. And as always, have a great day.